Good evening, everyone. This is Madhusmita. I welcome you all back for the day 3 of the AWS Solutions Architect Bootcamp, brought to you by AWS Cloud Clubs under the Center for Innovation and Cloud Computing and DevOps Center. Today, it's all about performance. High performing architects aren't just buzzwords, they are what they make great products stand out. We are excited to have Miss Kathleena with us again, ready to break things down and show us how it's really done. Let's gear up for another hands on practical session and build better together. Welcome, ma'am.
Can you hear me now? Okay, good, good. Okay, then I will share my screen and start with the presentation. Okay, so this is our third lesson. In this lesson, I will show how to design high-performing architectures with three different services. Um, First, I will present S3 and CloudFormation. I have talked a lot about S3, and finally, I will show you how we can use it. But this will be S3 with CloudFormation. Why? Because I also want to show you how you can reuse a template, a CloudFormation template, to recreate an S3 bucket in any account you want with only lines of code, so you will not touch the console that much. I will also show you how we can make an EFS mount target, and I will show you later how that is done. But uh, in a summary, with EFS, multiple EC2 instances can share the storage. So the storage is shared by many instances, and this also provides high availability. And this is absolutely necessary for high-performing architectures and also scalable storage solutions. And then I will show you um, how DynamoDB works. We will create a table and we will make queries and everything. And this is DynamoDB is in many domains of this exam. So I think I have to show it to you how it works. And it also falls behind in the determine high performing database solutions camp, because DynamoDB is serverless and you don't have to provide any infrastructure, and it is very high performing. Okay, so because we will see S3 and CloudFormation first, I'm sure you know about S3, but I will talk a bit about it anyway. So S3 is an object storage service, and it is designed for scalability, durability, and availability. Scalability is if we have many requests, the bucket will have the capacity to respond to those requests. Durability it is that it is durable, so it stands the test of time, and also availability is that it is available in many availability zones. And S3 stores data as objects in buckets. So in an S3 bucket, we can upload documents, code. We can upload images, for example. And there are many use cases, such as backup and restore. So, for example, we can upload our CloudFormation templates in an S3 bucket. And then if we want to restore those CloudFormation templates, we can do so. We can also host static websites. So a static website consists in an HTML and CSS code. And if we store an HTML and a CSS codes in our bucket, and we enable static website hosting, we can host our own websites very easily. And we can also use it as a data lake foundation for analytics. So for example, with Athena, if we store our logs in S3, then we can analyze it with SQL. So with the things we have already stored, we can make queries and we can use it as a data lake. And also we can use it as an application data storage. So as I said, images, logs, documents, etc. One of the features that S3 has, and it is very handy and very important, is the different storage classes. So, for example, S3 standard, it's the standard object class. Object class. But if, for example, we have audit logs and we don't see them very much. So for example, we only check those logs once a month, or we must retain some logs for auditing purposes in the future, but we will only see them in the audit. We can store them in a Glacier kind of object, in S3 Glacier, for example. So S3 Glacier Deep Archive is for objects that we see, I think, once a month, maybe. And the benefit of these storage classes is that with less access, if with the buckets in the right, storage is actually cheaper, but retrieval of the objects is more costlier than the ones in S3 standard, for example. So we must play with if we don't access those objects very much. And there is also a very cool class called S3 Intelligent Tiering. And based on the access of the object, AWS classifies the object in the class that will save you the most money. So if we don't access an object, for example, after 30 days, then it will transition to another class that is cheaper. So that is also a very good feature of S3. So I will show you how we can create a bucket and upload an object in S3. And I have a CloudFormation template ready for you. I have it in the GitHub repo. The GitHub repo is in this link. So I will share it with you. And it is the session 3 .md, so Markdown file. So to upload a CloudFormation template is actually very easy. We can upload it via the CLI, but so the command line interface, but I want to upload it with the AWS console, so it is more clear for you. So these are some stacks that I have. And first I will show you guys. I will upload the code and then I will show you what the code consists of. So what does the code do? What does the code mean? And what resources are referenced there? Okay, so this is the same template that I have in the GitHub repository. So the first part, this AWS template format version, this is always the same, and this indicates that this is a CloudFormation template. And then we have the parameters section. Here we can put some parameters we want to reference later in the code, and we can change this during creation. You will see this, but the default name for this S3 bucket is your name slash your name S3 bucket. But a thing about S3 buckets, they must have a universally unique name. So no two buckets in AWS can be called the same in the whole world. So you must create a name that doesn't exist. And the technique that I use is that I create my templates with my initials. So my full name is Catalina Paz Rodriguez Sanfuentes. So CPRS, and then the name. Okay, and you can do this yourself. And if your initials are common, you can also add numbers. But this is a very useful technique to make unique names. Okay, so these are the parameters, but then we have to create the resources. So this is a login bucket. I will show you the main bucket first for clarity. So this is the main bucket. And as you can see, it is called my S3 bucket in the template, but this is not the name the bucket will have. Okay, this is just for clarity in the code. So it is a type of S3 bucket. And then in the properties, the bucket name references the bucket name here. Okay, so the bucket name will be the same as this. Why do we do this? Because we reduce error with parameters. And also it is very good for reusability. Then I said versioning configuration as a enable. Why? With versioning, you can upload more than one version for the same object. So you can have, for example, an object called report.txt, and you upload the first version, but then maybe you want to make some changes, but keep the original version, like when we use a Git control system. So this will make various versions for the object. And then I also said that I wanted to use, I want to encrypt the files. And it used this algorithm that is very common in the industry. But with this type of encryption, you don't have to worry about keeping encryption keys or anything, because AWS does this process automatically for you. And then it says login configuration. We can also create another bucket, which is called a login bucket. And this bucket logs all the actions we do in this bucket. So for example, if we upload an object or if we delete an object, this will be saved in the login bucket, which is referenced here. So then we can use, for example, this login data and analyze it with Athena, for example, and see at which time the objects were uploaded and the IP, from which it was uploaded, if we uploaded from a computer, for example. And then I also made this bucket public. This is actually not a good practice, but I I don't know why I did it, but by default, all S3 buckets are the public access is blocked, but I made it public. And also here, we have the S3 bucket policy. I told you about bucket policies in lesson 1. And this policy states that public read get object, so reading object is allowed in all objects in this bucket. And this means everyone. So anyone can access the objects in this bucket. And then this is a section that is also very useful, which is called outputs. And in outputs, we can, when the bucket is deployed, we can see some attributes of the bucket. So for example, we can see the name of the bucket. We can also get the ARN of the bucket, and we can get the domain name, the website URL. And why is this useful? Because we can also reference the S3 buckets we created in other CloudFormation templates. And with this output section, this means that other CloudFormation templates can use these attributes. So they are exported for other templates in my own account to use. And you can see how powerful this is, how powerful CloudFormation templates are, because with this can be copied, you can share the templates, and this makes the development so much easier. And for example, even if you delete your bucket by error, then you can recreate the same configuration of the bucket with this code. And you can use also CloudFormation for deploying EC2 instances, for deploying containers. And when you deploy containers, you can even reference the Docker image, and it will be downloaded automatically. It is a very, very powerful tool that I use every day at my job. Okay, so I will copy this. Well, I uploaded it from my computer actually. So you can choose an existing template, but there is also the option of create in infrastructure composer, which is a visual way of constructing CloudFormation templates. I don't use it, but for example, you can create resources. So this is, for example, a user pool. I don't use it actually, but it is, if you don't want to write code, it can be useful. Also, I didn't mention, but these CloudFormation templates can be written in JSON or in YAML. I think I have this actually in the, okay, here. I have this information here. So you can use JSON or YAML, and some of its use cases, as I said, for example, you can launch a multi-tier application consistently. You can automate infrastructure deployment and rollback. So, for example, even if you store your CloudFormation templates on GitHub and you use GitHub Actions, you can make it so the template deploys automatically with every push. Very, very powerful. And you can also simplify resource management in large-scale environments, and you have all your resources in an easy-to-understand document, and you can keep track of everything you have. Okay. So let's go with uploading the CloudFormation template. So I write every template in YAML because YAML is easier for me to read than JSON. But it has no difference. Okay, so the stack name will be the name of the CloudFormation stack, but not the bucket name. So this will be the name of the stack that we can then search in CloudFormation. So the name will be S3 demo CloudFormation, and the bucket name, I will see if this is available. Maybe it is not available. If the name is not available, it will say that the name has been used by somebody else, okay? Then we keep these as default settings. Also, if your template has some syntax errors, the errors will appear here. So, but we don't have any syntax errors. So I will submit it. So here are the events. So it is deploying. It says create in progress. And here, oh, yeah, because I have to delete this because I created, it failed. Why? Because I already have an S3 bucket called with the same name. So when a deployment fails, you can just delete the template and it will delete all of the resources that it created. So I will create the stack again, but with another name. Demo S3 template. Okay. This will not give us errors, so don't worry about it. So as you can see, more events have appeared. First, it is creating the template itself. And when a template is uploaded, it gets uploaded to a specific bucket in S3, which is created automatically, in which all your CloudFormation templates reside. I think okay, so it has already deployed. So the resources, it has created 3 resources. So the resources it had created has been the bucket, then the bucket policy for the main bucket, and then it has also created the logging bucket. And in the outputs, you can see the export names and the values. Okay, so this is the ARN, and you can reference it anywhere. It also has the website URL. And then here are the parameters we have used. And here is the template. Okay, so we can see our bucket now. And I want to show you that the policy is here. So here is the bucket policy. Very good. Here is the bucket policy. And if you wanted to create a static website with S3, you can follow the documentation. It is very easy to do, but then you have to enable this. And you enable it in static website hosting in the properties tab. Okay, so to upload an object, we can also upload it with the CLI, or we can upload it here. I will upload it here. I will upload an object, which is a cat.jpeg, which is my boyfriend's cat. I will upload it. You can upload multiple objects at once, and you can also upload folders. And in theory, when an object gets uploaded, um, this is later logged into the logging bucket. But the thing is, I can't show you now because the logging appears after 30 minutes or an hour or even more. So, but I have created another bucket earlier, and I can see if the login happened or not. But that is a thing with login buckets. No, it hasn't been uploaded, but okay. And if we want to access this object, every object has a fixed follows the directory structure and everything we have put in the bucket. So the object URL is the name of the bucket, and the region it resides in. I think all buckets are in US East 1 region, I think, or no, I don't remember. Don't take me on that. But I will log in incognito mode to prove that the object is publicly accessible. And here it is the cat that I have uploaded, as you can see in incognito mode. And I want to show you another feature of CloudFormation, which is deleting the bucket, deleting the stack, sorry. When we delete the stack, every resource gets deleted. But this is also very useful because if we upload everything with CloudFormation, then we don't have to worry that the services are running. So this also saves costs that way. So we delete the template, and then it will say delete in progress here. And it has deleted the policy first. Oh, it failed. Okay, why has it failed? Okay, it failed because my bucket is not empty. First, we must empty the bucket. To empty a bucket, we have to go in the buckets menu, and then here, empty, and type permanently delete. Okay, then we can delete it. So we will retry a delete. So we can force the deletion, or we can keep the objects, but retain the resources. But I want to delete the whole stack with its resources. It seems it has deleted the main bucket. Okay, so everything has been deleted. And if we reload this page, we will see an error because the bucket does not exist. I also wanted to show you the bucket in which all my CloudFormation templates reside. So, for example, here, there are many CloudFormation templates, and these are stored automatically in this bucket, so you can check them later if you want. You can download them in the files. Okay. So this has been CloudFormation and S3. CloudFormation is actually my specialty in my job. You can combine it with GitHub Actions. You can store them in GitHub repos, but you can also store them in other Git versioning systems. And there are also native AWS services you can use to automate this. So, for example, in my company, we use a service called AWS Code Catalyst, and we can make custom workflows for deployment. And in these workflows, we can also lint the template to prevent errors from happening. So a very powerful tool. Then another service that I want to show to you is Amazon Elastic File System, so EFS. And EFS is an NFS file system that you can use with your AWS Cloud resources or even with on-premise resources. And it grows and shrinks as files are added or removed. And this can be accessible for multiple EC2 instances at the same time. And data is stored redundantly, so many times across multiple availability zones in a region. And some use cases, it can be used for shared file storage for web servers, and also persistent storage for containers and serverless functions. So because containers do not keep data do not keep session data, I think when they are reloaded, you can use this to keep a persistent storage, and for serverless functions as well. And also lift and shift of enterprise applications require POSIX compliant systems, file systems. So POSIX, I think it's a standard uh, for files in Unix. So Unix is for Linux and macOS, I think. And in this example, we have is two containers here, so one here and one here, and they both use the EFS file system. And I will show you now how we can deploy and use Elastic File System, and also how to, if you remember, we created EC2 instances in the last session, but here I will tell you how to make the EC2 instances more quickly using the AWS CLI. So I obviously don't know all the commands by memory, but I have them here in the EFS, the EFS section of my GitHub repository. So to use the CLI, we don't have to be on the service, but okay, so we open this, which is Cloud Shell. With Cloud Shell, you can use the CLI in AWS console, but you can also do this if you have configured AWS in your own computer. So here is the terminal. I will see if I can make the text bigger. Here. I think this is bigger. Okay. So first, if you remember, to create our instances, we have to create a security group. It is already created. Okay, I will I will have to delete because obviously I did this first to prove that it worked. So I have to delete the resources. I will see if I have to delete anything else. I don't think so. Okay. Okay, so this user group has been created. This is a security group called Storage Labs, and it has this description SG, so security group for EFS storage, and this is the group ID. I will note this group ID down in my text editor, just so I can reference it later. Okay, so now we have created the security group, and we will create a rule for this security group. So this rule authorizes TCP access for every IP in the world for port 22. And this rule has been applied. Then we will create the instances. We will create 2 instances to prove that the storage is shared. As you can see, this is much faster than doing it with the AWS console. So we specify the EMI, so the image of the instance. In this case, this image is an Amazon Linux distribution, and it will be deployed in US East 1 in the availability zone US East 1A. And the only thing we have to change here is the instance group ID that we have pasted and we have copied earlier. To paste, you have to paste with Control Shift B. Or, oh no, okay. So, no, Control B, just Control B. Okay, so it says that the instance has been created, is being created. Then we will check in the console if it is actually being created or not. And we will create the other instance. And then apply the rules. So as you can see, everything is the same besides the availability zone, which is just East 1B. So let's see if these instances are actually being created or not. As you can see, they are being initialized here. I will also delete this instance, which I don't want to use. Okay. So then we will also authorize ingress for port 2049 for our security group. So only instances with this security group can access this port. Ah, okay. This error was because the security group I used when testing this was had obviously another ID. So now it works. Yay. So let's wait until the instances have finished initializing. So because we will enter into the EC2 instances, because we have to install some things for the EFS mount points to work. I think I have forgotten to create the EFS the EFS file system. So I will create it while the instances are being created. So we go to EFS. We create a file system. The name can be anything you want. I will put my EFS 001, and I will reference the availability zones in which the instances are. So I will open another tab to check the security groups, the availability zones, sorry. So we leave this as default. But here we reference the security groups and the availability zones. So I will remove all the other month targets and just leave 2. So the security group was called Storage Labs. So we can search it easily here. But I just want to make sure that we have the right availability zones, because otherwise this will not work, okay? So let's check USIST 1A and 1B. This is correct. So let's just create it. Okay, so the instances are already running correctly, but we have to wait for the EFS file system to be created, and it has already been created. So let's enter into the first instance and install the things that we required for an NFS connection. So to connect to an instance with the AWS console is very easy. You have to select the instance, and you can enter in many ways. So for example, if you want to enter with to your instance with your own computer via the terminal, for example, with this terminal, you have to download a keeper, create a keeper, and then this is the SSH command ready for you. You just paste it and then you in your terminal. But we will use EC2 Instance Connect, which is actually one of the most secure ways of connecting because we don't use any key pairs. So only people with access to only this user can access this instance. So we will connect. So as you can see, it has Amazon Linux installed, as I said, from the AMI image. And I want to clear this text because it is kind of distracting. So to clear text in Linux, you just write clear or CLS, and the text has been the terminal has been cleaned. So first we have to install NFS utils. This command means sudo yum is the package manager for Amazon Linux. And I think Amazon Linux is based in a specific Linux distribution which uses this package manager. Actually, I will search for it. Okay, so it's based on Fedora Linux and CentOS. But if you, for example, use Ubuntu, you will not use Yum. I think you will use Snap, for example. And this checks that NFS utils is already installed, then we will make a new directory or a new folder called EFS mount point. And here we will reference our file system to this mount point. I will edit the command here because I have to paste something. I have to paste the file system ID from our file system, and this is the file system ID. As you can see, this is a URL, and it references the region the file system resides in. So we just copy this, and this will mount the EFS file system. And I want to go into that folder because this will be the shared folder, and I will create some files to actually check if the file system is shared between the two instances. So I will create a file called text1.txt. Sorry, I have to do this with sudo. Sudo is admin access or permissions. And I will put some text in it. So I use Nano, which is a text editor in the Linux terminal. And I just will write, I'm called Catalina. And then I save it. Okay. And here the file system has been mounted in the first instance, but I also have to mount it in the second instance. So I will just close that tab and open the second instance. So we connect using the same method. Check if NFS utils is installed. And then I have to, I think, create the mount point and then mount the mount EFS file system. And as you can see, the text I created in the other instance is also available here. And to double check, I will check if the text has the same contents. So to see the contents of a text file in Linux, you can use cat. Cat is not from the animal cat, it is from concatenate. So, and it also has the same content. So, yay, we have achieved mounting an EFS file system. And we can mount it to other instances. I think we can even, and well, this is very useful, as I said, and it is essential that you know how to mount EFS file systems, how EFS works, and you also will have a lot of questions about EFS, but more technical questions that are out of the scope of this class because of time constraints. but it is a very used service in the industry. And I will delete the. I don't think if I had to delete the file system first, because I want to make sure that I don't get billed by this. Okay, so it says the file system cannot be deleted. First, delete its mount targets. I can see if I can delete the instances first. So they are shutting down. I will also remove the security group. As you can see, I have a lot of junk security groups. So it is good practice to remove everything if you don't want to use it later. I can delete it because instances have not been deleted yet. The second instance is shutting down right now. Okay, so now instance is running. Let's see if we can delete this. If not, let's see if I can delete the mount target here. It doesn't matter. I will delete them later. So we have time to see DynamoDB. Okay, DynamoDB, one of the most important AWS services. I actually have only shown you very important services in this section, the ones I consider that are used the most or the many questions in the exam are based on these services. So Amazon DB is a serverless, non-relational database, which is highly available. And what does non-relational mean? So NoSQL. In relational databases, so I will see lot. So in a relational database, it consists of columns and rows. And for example, in this image, as you can see, no, this is not a good one. Okay, as you can see here, for example, every row has all the columns with data. So everyone must have a student ID, everyone must have a forename, everyone must have a surname and the date of birth. But in non-relational databases, we can have, for example, someone that doesn't have a date of birth in this table. So I have an example in the slide in which we have a table called products, and every product has a product ID and a type, but as you can see in the attributes, not everyone, for example, has all the data, and the schema is defined per item, not per table. So, for example, here we have a movie called The Kid, which has the genres of drama and comedy, and Chaplin as an actor. But then we have, for example, a song called Partita Number 1, which doesn't have a composer or a year. So as you can see, this is more flexible than a relational database. one of the benefits of having non-relational databases is that we don't have to define the schema, so the required fields for all objects beforehand. We can create these as necessities arise. And also it has a key value and document data models. And the use cases are real-time bidding, so well, bidding and gaming applications. Real-time is the key word here because DynamoDB is really fast. Also, serverless web and mobile backends, IoT device data storage. Also, when you see IoT in the exam, many times it has to do also with real time. Because IoT devices send a lot of data, and usually we want to those devices to react in real time. So we use DynamoDB, and we use, for example, Kinesis data streams, which is another real-time solution for these use cases. And session management. For example, if we have an application running in a container and we want to keep the session data, we can store it here as well. And I will show you how we can make a table in DynamoDB. This exercise is from the official AWS documentation. If you want to learn how to use any service, I recommend you to search in the AWS documentation. And we usually have this getting started with section, and it has very easy tutorials for you to get acquainted with the service. So we go to DynamoDB. I will keep this open, the documentation open, because I have to copy some code. Because we will also be doing some steps with the CLI so we have more time available in this session. But creating the table we will do with AWS console. So to create a table, here in yellow it is created table. And for the table name, I will put music. The partition key will be artist. The partition key is the same as the primary key in relational databases, and a primary key or partition key must always be a partition key should preferably be unique between. So, for example, a partition key can be an ID, for example, but in this case, it will not be unique. In relational databases, the primary key should be unique, but here it can also be reused. And the third key will be song title. As you can see, this will be a table about music. And we leave the default settings. So I will use the default settings, but I just want to show you that we have different read-write capacity settings. And with provisioned, we can give our table beforehand a desired capacity. So for example, when we make a lot of requests, it doesn't throttle and it can handle the demand well. And the reads, for example, don't take too much, etc. But we will keep everything everything as default, and we will create the table. I have the same problem. I already created a table called music before, so I will delete it. It has been deleted. So let's see if we can create the table. So it is being created. Let's open the table. And well, to refresh some things we talked about in the last session, I talked about point-in-time recovery, I think, and we will enable this for DynamoDB, and this will help us if we accidentally, for example, delete the table. If we delete the table, but point-in-time recovery is enabled, we can retrieve the data we had. Okay. So we already have the table. Let's write some data. I will do this with the CLI. The instructions here, for example, are with the AWS Management Console or with the CLI. I will see if this works in AWS CLI, in Cloud Shell, sorry. If not, well, we had to create them by hand. To paste multi-line code, okay, here. Let's see if the data has been written. So to see our items here, as you can see, the items have been written in the table, and we can see them here. So the artist is the partition key, and the songs are sorted alphabetically by song name. We can also update data. So I will do this manually as an exercise. So for Acme Band, I will edit this. And this can be songs about cat. I like cats a lot, so I will put cat there. Save and close. And then, as we can see, this has been changed. Another thing that I want to talk to you about, DynamoDB, which is very, very important, is the difference between scans and queries. And this can be a pain for many people because scans, if you have a very big table, can be really expensive. What is a scan? A scan is a scan scans your whole table and retrieves all of your data. This can be very costly if your table is very big. So for not to do a scan, you can do a query. And with a query, you can get data with a filter. So for example, we can retrieve only the items we have an artist with the name of Acme Band. I have seen cases in which people do scans and they it can get really expensive, because if you make a scan, every time you want to retrieve, for example, one value instead of a query, it can get really costly very, very fast. And I think there have been startups, for example, that have had really big bills because of DynamoDB scans. For example, this um, let's see if I can show you. Mm, oh, I can't find information that fast, but trust me, then you can search on YouTube and all the videos will tell you, please use queries and not scans if you don't want to retrieve all your items in your table. And we will make a query. So to make a query, we have to select our table. We only have one table in this account, so very easy. And here in partition key, we will query for only songs from the Acme band. And then we will run this query. So as you can see, only items from the Acme band artist have been retrieved. And as you may have noticed, for queries, we can only make queries with the partition key artist. If we want to make queries with other attributes, we can create other table called global secondary index indexes, in which you can query your data with other attributes that are not your partition key. Let's see if I can find a good example. Okay, so for example here, here in the original table, the queries are made with the partition key called partition, but then we can create a global secondary index in which the partition key becomes this pink attribute. So we can make other tables to use global secondary indexes to make queries with other partition keys. And I will also will delete this table just to don't have more junk in my account, because I study a lot making practical exercises, workshops, and if I forget to delete my things, then sometimes I get extra bills. So I will delete it. Well, it says that it is deleting. For example, I have another table which is called website visitors. You can count the visitors in your website um, with DynamoDB as well, and you can make it auto incremental. So very, very useful to check your visitors. Well, it has been deleted. Um, so yeah, this has been the third session. Um, I have really loved to have this session with you. The next session will be about cost management in AWS, and we will see how to, for example, calculate how much an AWS project will cost, and it will also be hands-on as the latest two sessions. And that session will be on June 19th, I think. So we will not see each other for a while, but I'm really looking forward to that date. And thank you very much for attending this hands-on session. Also, here are the references and sources. And as always, we can connect. You can send me a message on LinkedIn, and you can check my repo if you want to also make these exercises at another time. And well, thank you very much. I will stop presenting. So if you have any questions now, you can ask me. Um, so yeah, and thank you very much for listening, guys. Okay, so it seems people are leaving, so I don't know if the organizers want to deliver a message for us.
Good evening, ma'am. Hello, everyone. I'm Namrata, a member of the PR Associate and Outreach team, serving as a PR Associate at AWS Cloud Club, St. Joseph's Group of Institutions. As we reach the end of our session today, on behalf of AWS Cloud Club at St. Joseph's College of Engineering, I extend my sincere thanks to all of you for being the part of day 3 of our Design High Performing Architectures. A special thank you to Ms. Catalina Rodriguez for sharing her time and invaluable insights for today. Gratitude also goes to our organizing team and every participant for your energy and involvement throughout the session. As we wrap up today, let's carry forward the knowledge we have gained today and stay committed to building with purpose in the cloud. We'll see you all in the 19th of June for day 4 Design High Performing Architectures. Until then, stay curious, stay cloud driven, and keep building. Thank you all. Thank you, ma'am.
Bye. Thank you very much. Have a nice night.